Welcome to a demonstration of ON Semi's lighting tool. It's actually a lighting tool and a DC-DC tool, but most of the components in it currently are lighting based. There are a couple of ways you can get to the tool. One of the easiest is to go directly from arrow.com, and you can see here on the web page it's arrow.com. Click on electronic components, and then click on Online Design Solutions, and this will take you to Transum's Design Web. On the Design Web, there's the Start button here. You click, and it allows you to search the online designs either by application or by companies. Applications by lighting, solid-state lighting, and now we pull up the ON Semiconductor stuff. Now, all I can do is I can click Start GreenPoint here, and that will take me into the tool. But before that one, I want to show you another way to go into the tool, especially if you're highlighting ON Semiconductor. ON Semiconductor, on their main page, www.onsemi.com, has a nice link here on their page that you can just click, and that will also take you directly into the tool. But we're going to go into it from the Design Web, so I'm going to go into it by just starting GreenPoint. And the first thing you'll notice is you either need to register or need to log in. If you need to register, you just click on Register. It'll take you to the registration page, and where you have to fill in your user information, or you can go back. Since I already have registered, I just need to log in. So I'm going to log in as myself. My password. Now what this is doing, this is one, letting ON Semi know that I am in the tool and going to do some designs. And it also registers me so that I can save and I can share designs once I complete that. So the first thing you see here is there's the GreenPoint page with a list of parts available, quite a few parts available here. If I click on LED lighting, you can see that one's lit. That shows all of the parts targeted for lighting solutions. And if I click DC-DC converters, you can see that there's one part sitting out here that's available for DC-DC converters. But since we're talking about lighting today, I'm going to go into the lighting tool. So there's a whole range of parts here. You can see I have AC-DC parts, I have DC-DC parts, and then I have some linear parts. What I'm going to look at today, I am going to pick the NCP 5030 because it's a simple buck-boost converter, and I'm going to design around that. So in order to select this part, I just click on the Design It button, and it's going to take me to a design interview. And so on this design interview page, you can see I have a set of user inputs. So my input voltage, I have a range for my input voltage. I have a requirement for what kind of LED I'm going to use, so the forward voltage, the impedance, and the current on that one. And I can pick a range of LEDs in series. So in order to do this one, I'm going to stick with the defaults on this one, and I'm just going to generate the design. But at any time, you can come in here and change these user inputs. So I could change the user input to be, say, 4 volts to 5.5, and then just generate that design. And it will set up my circuit slightly different based on those user inputs. Now, when I get to this page, you can see I've generated a circuit that's specifically designed for those user applications, and all of the components have been calculated based on those design requirements to complete this schematic. So when I complete this schematic, I have the option now to go in and do an analysis on that schematic. So I can do an AC analysis. I can go in and do a steady state analysis where I'm going to look at how this circuit is running in steady state, or I can do a transient analysis, which is going to show me how this circuit is going to look due to the effects of dimming. So with this little dimming source here active and running. And you can see I've got waveforms for all of those tests that I've run. Now, if you look at the schematic page, there's the option to look at the results directly. So I could look at the AC results. And what that's going to do is pull up basically the web scope, which is a very handy way to look at the waveforms in detail. And it gives you quite a bit of functionality. And you can see here I have my Bode plot of my gain and phase. If I really want to look at what's happening down here, I can click on this and zoom in and look at what's happening here, and you'll see my axis and everything has been zoomed in. Let's say I zoom in very, very close. Let's say this is, I don't want to see this zoom in. I can always reset that zoom level with these little controls here. So there's a whole host of controls on the side. Feel free to use those. You can zoom out or you can zoom in using these controls. Personally, I like to use just the drag and click. I like to use the drag and click method. Marquee zoom. And now if I drag on that one, you can see I can zoom in on that. I can look here. Now there's a couple of other interesting items that you can do with this one. You can, if you see these two little triangles up here in the corner, you can drag these and actually set those at a couple of different points here. And as you see here in these little points right here, you can see that it's following the frequency. So I can see that my crossover here from my gain is right at about 7.6 kilohertz, or excuse me, my crossover is about at, it's the F2, it's the F1, which is this marker, and it is at about 16 kilohertz. Now, I'll show you a couple of other things you can do on the waveform tool. I'm going to go into steady state. So if I go to steady state, you can see that right here I only have two waveforms shown, and that's because these are highlighted. I can turn waveforms on, or I can turn those waveforms off, and since those are kind of boring waveforms is why they were turned off. But I can also take my cursors, and let's say I want to look at the frequency that this thing is switching at. I can measure between the two pulses, and right now it says that I got 1.4 microseconds between this cursor and this cursor. If I go over, you can see it's going to give me that in frequency. Let's say I want to measure what the voltage is at this cursor. You can see on the waveform right here, on this red waveform, it says that it is 4.7 volts here. And if I drag this one, over, you can see that it's actually slightly negative at this point. If I want to do a measurement, the average measurement between these 2 points, I can simply drag them to here, click down here, and click the average between the two markers. So the average M will give me the measurements between the two markers, and I can see that it's 4.738 volts between those. If I click average, that's going to give me the average for the whole waveform within this window. The average M is going to tell you, the ones within the parentheses M are going to give you the measurement between wherever your two markers are set up. A couple of other features that you can do here, and it's not so clear. Let's see. Let me pick another waveform here, and see if I can do it on this one. So there's a couple of other features here. You'll notice that the blue waveform is on top and the green waveform is on the bottom. I can highlight that one and drag it down, and you'll notice that the green waveform is now on top of the blue waveform. So the order that these waveforms are showing in the web scope are also the order that they are going to be displayed on top of each other. So if you have a very, very busy measurement screen, you can actually zoom in and pull what waveforms of interest you want to look at on that one. And plus I can actually turn those waveforms on and off. I can turn them all off with the X, or I can turn them all on with the checkbox. So that's the web scope. Now that I've done the analysis of this one, I have my screen here, and this one gives me a summary of all the waveforms. And you'll notice my hand clicks open here, and if you ever want to look at these in the waveform viewer, you can do that as well. Now, once I have a design done, I want to go to the BOM. And what the BOM is going to do is it's going to go into the database of parts that resides on the server and look for all available parts that have been set, that basically apply to that design. And there are a set of rules behind each one of these components that try to pick a reasonable component for the parts in this schematic. So, for example, my output capacitor C3, if I go into the BOM, you can see it's picking a 6.3 volt output capacitor. And all of these are available. Let's say I want to see what information is available on that capacitor. All I have to do is click on that link, and it's going to pull up the data sheet for that part. So I can go in here and look at more detailed information on the part. But there's a couple of other features with this BOM module that are kind of nice to look at. If you'll notice this little piece of paper with a magnifying glass on it, it says I can search for a different part. So let's say for some reason I know that the AVX parts are not what I want. For example, this one, let's say it's an X5R, and I don't really like to use X5R. I want to go with an X7R. I can go in here, and these are the rules that have been set up to go search for those parts. And what it's doing is it's finding an X5R part. Well, I can come in here and look for my temperature coefficient and say, you know, I really don't want that one. I want to do the X7R parts. So what I'm going to do is apply those filters, and now it's going to narrow all of those down to the X7R parts, and I can choose an AVX or a Chemet part. Well, let's say I don't want to pick AVX parts, and I only want the Chemet parts. So I can go through here my list of manufacturers that happen to have those parts and click Apply Filters. And now it's going to narrow it down to only Chemet parts. And if I want to use that part, so right now you can see up here, I have the AVX part. All I have to do is click on this little select, and you'll notice that it jumps back to my BOM, and it's picked that part that I was looking for. And I can do this on all of the parts. So let's say I want to switch to Chemet parts on all of these. All I've got to do is click Apply Filters. It's going to pull up the Chemet parts. Let's select those. So for C2, if I know I want to use Chemet instead, I just click on those, Apply Filters, and pick a Chemet part. And I can repeat that for all of these. But let's say I really don't want to do it on this part, and I want to go back to what was initially recommended. So I can hit the reset button here, and it'll reset all my filters back to what was there, and then all I have to do is search for the parts there. If I want to use this AVX part, I just click it, and it applies it. Now, I've shown you the BOM tool. Now, in the BOM tool, you can select a host of distributors. ON Semi happens to use Arrow, DigiKey, and Mouser as their distributors. Well, I'm going to select the Arrow as my distributor, and you're going to see here that not only can I see what's in stock and what the price is for that price break, I can up that one, and I can actually look at what's in stock and get the pricing on that one. If I wanted to, I could actually go to checkout, and that would take me directly to Arrow. There is one other thing here. Let's say you've got your BOM here, and you want to download it. All you have to do is click on this Excel, and it will save that one as an Excel file. And when it pops up, you can see that I can look at my parts in Excel. You'll notice right here on L1 that I'm not having any luck finding this part in Arrow. So if you look here, it's popped up the Excel, and you can see my list of parts that are available here. So if I look at this one, you can see that L1, in here at L1, I don't have a part selected. So I should really go back and look at that and see what I can do to fix that. So I'm going to go back to L1. And the reason it's saying user selection required is it's not finding something that specifically meets those requirements. And so it's looking for a 4.7 microhenry, 189. And I'm pretty sure that that one is probably either limited by the DC resistance or the DC current. And so what I'm going to do is I'm going to give myself a little bit broader window for DC current. And I'm going to up my DCR a little bit, apply the filters, and you'll see now I'm able to find a part. This Murata looks pretty good, so I'm going to pick that one. And so now I have the part. So when I download the BOM, you can see I've now managed to get that part into my BOM, and it has the part available in my list here. Now that I've done that, I'm able to go to a design summary, and in that design summary, not only do I get what my user inputs were, I get the schematic that I used, the list of parts that were created in the design, all of my waveforms that I created, and I also get the ability to save that file as a PDF. So if I click on PDF, it's going to create a PDF of that file so I can save it and store it on my machine. And you can see it's working on that one right now. And I'm going to open that with Adobe. And I need to share that one so you guys can see it. So what I'm going to do is share. I'm going to share that application. And so what you see here is a nice PDF file that has my inputs, my circuit, the BOM, and all of the waveforms. And I can take that file and send it to save it on my computer, or I can send it to a customer. I have a whole host of things that I can do with that. But let's say I don't. Let's say I instead of trying to create that file and saving it with the customers, you'll notice up here in the upper right hand corner I have a set of buttons that I can go to, and this is what we call our design manager, which allows us to actually save designs that we created. We can share those designs with other people, or we can actually open designs that have been shared with us. So for example, for this design, first thing I'm going to do is I'm going to save this design, and what I'm going to do is call this and I'm going to save that one. And you'll see that that one has successfully been saved. And now you can see that its name has popped up here, which means that I'm actually working on that design. Now, let's say I like this design. I want to share it with someone else, say a customer or another application engineer. All I have to do is say click share. And I know that there is someone I want to share that with, so I can click on Share by Contact. I'm going to share it with one of the engineers here at Transom. I'm going to click on that. And you can see here I have a whole list of different circuits that I have available. And let's go to the next page. You see I've got 18 entries, so I need to go to the next page. Let's find that one. Here's the one I want to share. And so what I'm going to do is I can give Trevor read-only access, or I can give him read-write access. And so right now I'm going to give him read-write access so that he can work on it. So if I hit update, now Trevor has the ability to actually look at that circuit and make changes to it. If it's someone that's new to me, I can always send them an invite to come look at it, and I just have to type in their email address, and it will create an invite to go to that customer to actually get registered for the tool and look at that design. And that's how you share a design. I can also go in and I can open designs. So right now we've been working on ON Semiconductor design. Let's say I want to go in here and look at a design by someone else. So I can go in here and look at all my designs, and I'm going to look for one that is owned by Laurent Jenk, who is actually the product manager at ON Semiconductor. He shared a design with me, so now I'm going to load this design. Okay, so I can look here. So Laurent shared this CAT 4201 with me. This one, you can see it's actually a completely different circuit than the one that we were working with before. A couple of other items to look at on this one. You'll notice here there is a help button, and it will pull up a brief help on how to work with this page. Or you can download a complete help manual, and that will go through all of the steps in this tool. There's also a feedback button. So if for any time you get into a situation where something's not working right, or you think, hey, this part would be kind of cool to have, you can go into this feedback button and type in general feedback. So like here, if you say I want a different part, I can say please add a new part. And you can see here, so when I click this button, it's going to send an email to the support, and it's going to request that new part be sent. And I'm not going to click that button because then that creates a support file that I have to go deal with. So for now, I'm not going to submit that one, but it's an easy way to submit your support ticket. Again, let's go to the design summary. If you're on a public computer, you can always hit log out, and that will take you out of that will also take you out of the tool. And that is about all I have for the tool. So one other item, if you click on Semi, you can always get taken back to the ON Semi main page. So that's about it for the tool. I hope this was helpful. Feel free to go into the tool and look for lighting solutions.
This is a basic overview on the Infineon Light Desk online LED design tool. First step is to get logged into the tool. If you do not have an account, simply register and provide the necessary information. If you do have an account, provide your username, password. Select Go. The Infineon tool offers two main applications, AC to DC as well as DC to DC. In this video, I'm going to cover the AC to DC offline LED driver tool. I'm going to go ahead and select the non-dimming parts. This takes me to the design input and part selection page. Here the user has numerous design parameters to enter, which is search criteria for the selected drivers. For instance, min and max input line voltage, line frequency, LED package, forward voltage, forward current, ripple voltage. You also have the option to select a configuration such as dimming and non-dimming, and whether or not you want an internal or external FET. I go ahead and select a driver. This gives me a list of all the appropriate parts that fit my description. If you notice down here, there's some highlighted words. This is telling you what doesn't fit your search criteria. So these two parts down here are dimming. If I change my configuration to dimming, select a driver, I should get one of those parts, which I do. I'm going to go ahead and select the ICLS 6021J, design it, and that brings me to my analysis page. Here the user has the option to run an AC input transient as well as a startup analysis. You can configure your analysis options here, adjusting your cycles or startup time stop time. I'm going to go ahead and run the AC input. Takes about a minute to simulate. One thing to keep in mind is that the schematics you see here are fully interactive. The user has the ability to change any of these components you see here and then rerun a simulation. So changes to the schematic will affect your simulation results. Once that's done, I should have a results link that shows up here. And there it is. If I select that link, this should open our web scope waveform viewer. If you notice, you have numerous waveform groups on the top here. For instance, IC, switching, output, and input waveforms. The waveform viewer has full zoom capability. For example, if you want to select only the LED current, zoom in, then maybe you want to know the average current. These drop-down boxes have a list of multiple measurement functions available. From the Analysis tab, the user also has the option to do a redesign on the schematic. Here we offer a few more advanced design inputs for the user. For example, maybe I know that my circuit needs a 220 microfarad capacitor. I can use this custom value, then completely redesign my schematic using my new capacitance value. As you can see, I have my new value listed here. Also available on the Redesign tab is Transformer Design. Here we provide the user the list of the transformer details, such as primary windings, secondary windings, auxiliary, and also core and bobbin information. The user also has the option to edit these details. For example, if they'd like to change the magnetizing inductance, they can see how that would affect the rest of their transformer properties. You also have the Build tab here. This gives a basic overview of your transformer build. Moving on to the Results tab. This is a basic summary of my current design. As you can see, I have a list of my design inputs, as well as my transformer details. Schematic image, bill of materials, and simulation results, if there was any ran. The user will also have the option to download the MySimT simulator. This is Infineon's version of the offline symmetric simplest simulation engine. The user would also have the ability to download the schematic for further offline analysis. The last topic I want to cover for this tool is the feedback button. Most of Transm's design tools will include a feedback button. We encourage all users to please provide their thoughts, as this is helpful information. Thank you. This will be a basic overview of the Infineon Light Desk online LED design tool. I'm going to start by logging in. If you do not have an account, you'll simply need to register with the tool and provide the necessary information. Infineon offers two main applications for the Design Center. One is the AC to DC offline LED driver, and the other is the DC to DC LED driver. This is the main design inputs and part selection page. As you can see here, the user has the option of entering operating voltage, LED forward voltage, LED forward current, number of LEDs in parallel, and number of LEDs in series. If I select driver, I get a list of parts that fit my search criteria. I also have the Show Other Drivers button here. This will show all the parts available in the DC to DC application. Go ahead and analyze the ILD 4035. That brings me to my analysis page. Here I can run simulations, view results, edit component values, and further analyze my circuit. I'm going to go ahead and run the simulation. Keep in mind this schematic is fully interactive. You can edit and change component values as you please, and the changes will take effect in your simulations. Once the simulation is done running, I get my results down here. If I select the waveform graph, that will actually open our WebScope waveform viewer. In this waveform viewer, we usually have a couple groups for output and input signals. This waveform viewer has full zoom capability. If I zoom in here, move my measurement markers, can actually measure the switching frequency. As you can see, this is switching at about 285 kilohertz. The waveform viewer also has numerous functionalities such as RMS, average, min-max, and peak-to-peak measurements available. Moving on to the Results tab. This is a basic summary of my current design. On the left here, I have my user inputs, my bill of materials, schematic image, as well as simulation results. The user also has the option to download a PDF version of this summary. The next step in the tool would be to save my design. I simply give the design a name, and maybe a description, and select Save. This design has now been added to my available designs, which I can access at any point in time.